Thank you very much. And Arpit, come on up, please. There we go. We have Arpit coming up to speak to us about a software-defined network exchange. So just forward back there. Okay.
Hello, everybody. As you said, I'm Arpit Gupta. And I will be talking about software-defined internet exchange points. And this has been a joint work between Princeton, Georgia Tech, and Berkeley. So I have been working on this project with a lot of guys, Mohammed Shabazz, Laurent, Rujun, Nick Feemster, Jennifer Rexford, Russ Clark, and Scott Schenker. So I'll use this platform to ask this one question, that can SDN networks simplify network operations for inter-domain routing? And I will begin this with an example to make a case that SDN can be useful for network operations for inter-domain routing with this simple example. So what we have here is 3 ASs, and ASP has 2 edge routers, one in Atlanta, one in Washington. All these 3 ASs connect at an exchange point. So the operator for ASB wants to control how the inbound traffic enters its network. So either it enters via Atlanta edge router or via Washington edge router. So this has been a standard problem. I'm not creating a new problem. This is a very standard problem. And BGP provides various attributes with which you can play around. And there are various solutions how you can solve this problem. So one such approach is called selective announcement. And what you do here is that you add preferred destination IP prefixes for each router, along with the aggregated IP prefix which you are advertised here. So this is just one approach, but BGP allows you other attributes too, which you can play around. And these other attributes are AS path prepending, use of MEDs or community tagging, etc., etc. The important thing is that these attributes are, like these approaches are widely used by network operators for inbound traffic engineering. But the question is that, like, is it fine? Like, if people do have problems, or this is the ultimate solution? So let me discuss some problems with these solutions. And the first problem is that these solutions are inflexible. They're inflexible in the sense that these approaches can only influence the routing decisions just based on the destination IP prefixes. So you cannot do source IP address, or you cannot do inbound traffic engineering based on application type, etc., etc. Second thing is about complexity, that these solutions are relatively complex, and it involves intense configuration for multiple networking devices. And the third most important point is that these solutions are kind of unpredictable, because all these solutions are about tricking the remote party to influence their routing decision. And they break if the remote parties don't comply. So there is this element of unpredictability in that. Apart from that, there is this, so all these approaches are vulnerable to changes in network state too. Sorry. So going back to these problems, I would like to pose this question like, okay, we know that these problems, these current solutions do have some problems, but is SDN the answer to that? Can SDN provide us with a solution which is like simple, flexible, and more predictable? So let's try to answer that question with this same example and bringing SDN into the picture. And what I do here is that I replace the switching fabric for the exchange point with open flow switches and put an SDN controller over there. And now the operator for ASP, which was initially doing some BGP-based solution, will write an open flow rule in the exchange point. And this open flow rule can be as simple as shown in this figure, which is like if the destination IP is equal to some IP B1, then forward it to port 1, which is connected to Atlanta router or to the Washington router. And also because this kind of solution does not require any dependency on the remote parties, so this is more predictable. And another important thing is that since open flow rules can be based on any packet header field, so there is no inflexibility problem which we observe for the other solutions. So your inbound traffic engineering solution can be either based on the source IP address or application type, as shown in this figure. So I guess this example motivates us or gives us some insight that SDN can be useful for solving problems related to interdomain routing. So I would like to move forward because in this example we mentioned that we replace the exchange point switching fabric with the open flow switches, right? So I want to justify that why we do that. And before we discuss that, I'll talk about like SDN is widely used in campus networks, data centers, it's very popular there. But SDN for these individual network domains is very much different from SDN for the entire network or for the entire internet scale. And we don't see SDN for interdomain routing purposes much these days. And what can be the reason for that? And I believe the reason here is more about the deployment cost. I mean, we have some of the solutions of SDN for interdomain routing, but if the approach to apply interdomain routing, apply SDN for interdomain routing is by changing entire L2, L3 devices with the open flow switches, it will be a high deployment cost. So this takes us to the point that we thought that we should focus on internet exchange points. And these internet exchange points have this unique structural advantage, which requires that you just need to change the switching fabric of the exchange point, and it will affect large number of participants, especially for the larger IXPs, which have hundreds of participants. So moving ahead, that when we try, like, is making SDX or software-defined exchange point is as simple as replacing its switching fabric with the open flow switches? So the answer is, I think the answer is no. And the reason for that is, like, for most of the common SDN networks, it's about just one network administrator writing policies for the entire network. But what we have here is that we have multiple participants. And these participants want to write policies to affect the control, or to control the exchange data traffic at the exchange point. And so because they will write policies together, so there are two scenarios. One is that they have to write policies taking into consideration policies of all other participants, which makes it very complex and unmanageable. And the other approach is that they write policies irrespective of what other guys are writing about. So these are the few challenges. This is the important problem or important thing, difference between normal SDN networks and having a software-defined exchange point here. So we have to design an SDN controller for exchange point with the taking into consideration the fact that we have to minimize the complexity for participants to write policies. We have to avoid potential conflicts, and also we have to ensure security. So we have broadly two solutions for, like, applying SDX and managing the problems of multiple participants. One is the virtual SDX abstraction, in which each participant has its own view of the network. And second is the sandbox. So let me go ahead with the virtual SDX abstraction. So what we have here is that each AS has its own view of the SDX. So in this case, like, we have 3 participants, and AS A is shown to have its own view of the SDX. So it does not have a view that B has 2 ports connecting to the exchange points and all those gory details. It need not know about that. And what happens here is that because each AS has its own view, it writes the policy to the exchange point, assuming that it's the only network administrator for that SDX. So in addition to that, we have the concept of sandbox, in which each AS writes its individual set of policies, and that goes to the sandbox, which does a sanity check and makes sure that different ASs don't write, like, fatal policies or don't misuse the resources at the SDX. When all these different policies go to this SDX controller, it uses some composition operators to compose all these policies together and make one big composite flow set rule, which directs or orchestrates the exchange traffic at the exchange point. So far we discussed that, like, why or how SDN can be useful for interdomain routing. Secondly, we discussed that why we use SDN at the exchange point and what can be the challenges building it and how we solve those challenges. Now I will focus on some of the unique features of SDX which can make it more useful in a lot of practical applications. So I will start with this, that SDX uses auxiliary information. And what I mean with that is that SDX-based controller can have access to any kind of auxiliary information sources like RPKI or routing information from the route servers. And what this enables is that it makes it more flexible in terms that what kind of applications can be used with SDX. So just for an example, like we talk about application-specific peering. So what SDX can do is that it can take the routing information from the route server, and on the top of it, it can build application-specific peering in which two ASs peer just based on few application set. So all these kind of unique or new applications are possible just because SDX can have access to, along with the basic routing or peering behavior, it can subsume that basic behavior to add more fundamental features to it. Another thing is that it enables task offloading for participants. What it means is that, so SDN can have lots of benefits for the participants, but applying SDN in their own network means a lot of infrastructure changes. To avoid that, what SDN can do is offload their SDN-related tasks to the SDX. And this simplifies the implementation of various SDN-based network operations. So let us consider the example of wide area load balancing for that. So the scenario here is that we have an ASA which hosts 2 data centers, and it has lots of services hosted at these 2 data centers, and it wants to load balance the traffic between these 2 DCs. So traditionally what happens is that these AS or the service provider will basically use a DNS service for load balancing the traffic. For example, Google DNS resolver. And if it wants to do it in the SDN way, then one approach is that it makes changes at its edge network and replaces some of its edge routers with open-flow devices. But other approach is that it can offload this task to SDX. And what SDX can do for this AS is that it will announce the IP prefix for certain set of services, and all the traffic for those services will be coming to SDX. Now, this AS can write any complex load balancing algorithm at the SDX itself and load balance the traffic between the 2 data centers. And as we discussed before, SDN provides flexibility, so these load balancing algorithms will not be dependent on just on the destination IP prefixes, but also on the source IP addresses or destination or application types or different features of the packet header. And another thing which I think is very important is that ASs can control the exchange traffic remotely. So far we have discussed the example in which all the ASs are basically directly connected to the exchange point to have these kind of services, but that's not a requirement. So to consider that, let's think about this problem of preventing selection of paths via problematic ASs. So an AS figures out that there are a set of ASs which have some problems, their routers are down or some other problems, and it wants the downstream traffic to avoid these set of ASs. So it can write a policy remotely. It need not directly be connected to the exchange point. It can write a policy remotely at the exchange point and avoid these ASs path to be selected, or make the route to avoid the routing decision selecting these AS paths. Or we can extend the previous example we discussed about the load balancing. So we discussed that ASA was directly connected to the exchange point, but there is no need for it. And ASA can be remotely connected to the SDX, but still can have the load balancing task offloaded to the SDX. So far what I've done is that I've discussed some of the features which SDX provides, and we believe that SDX, because of these features, will be able to put more, to bring in more innovative applications and make tasks for network operators simpler. So I will talk briefly about what is the current status of the project and where we stand and what are the problems we are looking for. So currently we have an SDX controller running at Colo ATL exchange point in Atlanta, and we are connected with the Georgia Tech network. We are also connected to Southern Crossroad exchange point, and we are in talk, and I think within a week or two, we should be connected with the Internet 2 network also. We are also in talk with ESNet and some of the cloud and CDN providers. So The important thing about SDX is that it does not require any changes for the peers to get some services related to SDN. Peers can have their own traditional network, no changes required. They just need to pair with the SDX and define the kind of policies they want. So SDN for interdomain routing has tangible benefits, and SDX simplifies the usage of SDN for interdomain routing. So this is the message I want to give with this talk, and I'll request that you guys should visit our website on SDX project, and we are looking for networks to peer with us, and believe me that it's very simple to peer with us, and since we are connected to Internet 2 and connected to SOCKS, so it should be possible for a lot of networks to connect with us. And we will be releasing some SDX-based survey, and we are interested in knowing that what kind of applications do network operators desire from this kind of setup. And our work is open source, so people can go ahead and contribute to the SDX project. Thank you. Questions?
Any questions, folks? Okay. Well, thank you. Thank you very much.